You guys can see my screen.
Yes.
Yep, got it.
Perfect. Okay. So we have fairly large submittal. I promise it's not going to take super long to go through it all. But let's go ahead and get started. So our submittal covers a pretty wide array of equipment. Oh, my apologies. Sorry about that. So our submittal covers essentially the network riser. This covers the rough outline of all of the equipment that we have on site, and which Johnson Controls network engine that these points are going to, or these devices are going to. We have an example of an S&E panel diagram. We go over essentially the air handler units with their what devices they have on them, the sequence of operations. We also have a couple of quote unquote exception AHUs. So these are ones that have a slightly different points list. And this is due to equipment being provided that is different than the standard. Something to note would be like the outside air temperature lives on air handler 7. So that's why it has its own particular point schedule. It's because the points are different. We go over some basic wiring detail. We have a panel diagram. Then we get a separate exception for air handler 9 because this is a dedicated outside air system. Then we go over all of the variations of exhaust fans and their associated interlocked system. Same thing, you'll get a panel diagram. And then we go into all the different variations of fan coils. This includes 2-pipe, which is, I believe, just cooling only, followed by 4-pipe, which includes steam heat, as well as the variations in points being provided. Then we cover the site's heat exchanger. This is a pair of heat exchangers that serves pretty much anything that uses hot water on site. There's a pool heat exchanger, which is for the therapy pool. We cover some information about the isolation rooms, as well as their wiring layout and the flow layouts for the different rooms. We also provided so Antec is the manufacturer for these isolation room air valves, so we provided their controls points information. Next up, we have the PDU, or the package dehumidification unit. This serves the same space as the pool heat exchanger. And then lastly, we go over terminal units, as well as miscellaneous devices and other. So without further ado, let's get going. Let's take a look at the example of the network risers. We get a basic, this is just a basic MSTP installation reference. This covers anything from how the how the MSTP needs to be wired to basic network infrastructure stuff, as well as the standard wiring convention. I'm not going to go into too much detail about this because I could spend a lot of time on this, but this should be pretty standard. And from previous, working on your site previously, this has been pretty standard. So here's our first network riser. You can see this is kind of hectic, but we break this down into separate network trunks. So you can see this one is S&E 43. This serves the first floor, and it exists in the first floor IDF room closet. This is right at basically, if you walk in the front door, the sliders, this is that first hallway on the right. It's that first corner room. And you can see this network engine serves, and this is going to be a common theme with all of the network engines, it serves terminal units, a range of them. This says, address 7 to 11, so on and so forth. This serves the heat exchangers. And keep in mind, this network riser is not necessarily this is the exact, how do I explain this? This is not necessarily the exact layout from device to device. This is more of this is stuff that exists on this trunk. So yeah, you can see it's just pretty standard terminal units, lots of terminal units. Kind of the way that these are labeled. It's the building number, the unit number, or sorry, the unit type, and then it's the first number if it's served by another piece of equipment. So for instance, these terminal units are all TU 1.1. This implies that this is served by air handler 1, and this is terminal unit 1A. You can see like this one, for instance, is terminal unit 991A. So this is served by air handling unit 9, and this is number 1A. We've got some fan coils. These actually have kind of a smart residential thermostat setup. So these have your typical G, Y1, Y2, W terminals in them, but they speak BACnet. When we do our walk tomorrow, we'll get a little bit of hands-on these, just to take a look at them. We have a couple of fan coils like this, which are they're labeled 14A/B, and this is a pair of fan coils run off of a single controller. More of the same, cool heat exchanger, and yeah, PDU integration. So this is a third-party integration control that we get from the manufacturer of the controller is Corel, but this serves the pool dehumidification unit. So this is kind of just like a general layout. That's what one of our trunks looks like. You'll notice I followed this line, and that's because what was described on this previous page is that you want to essentially connect your devices in a daisy chain. So this is how the MSTP run is done, and it's depicted that way. So yeah, are there any questions? There's a whole bunch of pages for the network risers, and they all are going to kind of look similar. The difference is going to be which equipment is being served by which network engine and on what floor, right?
Okay, copy that. Yeah, nothing at this time. And then my maintenance chief for maintenance operations, Joe Dobbins, has joined us.
Perfect.
Thanks, Joe.
Cool. I'm gonna go ahead and move on. Again, it's more of the same. You can see this particular page is for the second floor. You can see it's more of the same, right? So the bulk of the equipment that's being provided with controls on site are terminal units. So you can see like this, right? Typical of 22. So rather than us put 22 individual controllers on here, we condense this to basically just show, typical of, we did the same thing here. So yeah, it's more of the same. So terminal units, fan coils, anything like this where it shows PMT, this is actually the Antec isolation room controls. So these come in a pair. You have an actual controller that has air valves, and then an actual like pressure monitoring device, which is essentially just I believe this is the thermostat and the
this is for also for the isolation room advice. This is one, but yeah.
I'm sorry, say that again.
This is the ISO room.
Yes, yep, that's correct. These serve the isolation rooms. Cool. And you can, so kind of the way that these are broken down, you have FC1 and FC2. These are field control buses. These are MSTP. Typically, these are split up by sections of the floor. So everything on FC1, for instance, is all going to be in the same section of the building, whereas everything on FC2 is going to be on a different section of the building. So these two isolation rooms we can see are essentially, they're on separate trunks. So we can infer that they're in separate, completely unrelated sections of the building, even though they're both on the second floor. Cool. There any?
And a quick question on those ISO rooms.
Sure.
Are they tied back into our Metasys, so the folks that sign into Metasys will be able to see that they're operating properly?
Yes.
Okay. And does so separate from the ISO rooms, I noticed we have a handful of like biohazard rooms. Are those pressurized, and is that do they have sensors that are tied back to Metasys as well?
That I'm not sure of. That might be wrapped up in our, we have a miscellaneous controls points part of our contract, but I think that's actually in a separate submittal. Caesar, I don't are you still on the call? You are still on the call. I don't know if you can speak to that, Caesar, regarding the miscellaneous. Maybe if he's here. Oh, he's actually not on the call any longer.
Okay.
Okay. My understanding was this was wrapped up in a change order, which I believe obviously it's been awarded to us. Not certain the state or the completion of that. I'm not certain of
Okay.
at this time.
So maybe
my
Justin,
understanding.
you could, yeah, maybe Justin, you could log it as a question for how are the biohazard rooms, how's the negative pressure being maintained there, and then also how's it being monitored if it doesn't get covered here in the miscellaneous section. Thanks.
Sure. Yeah, what I was about to say, my understanding is that these Antec controls are specifically for the isolation rooms, the patient rooms. So
Okay, copy that.
I don't believe any of these devices are being used for that purpose.
Okay.
Cool. Yeah,
Noted, Brandon, also, just so you know that I'm tracking.
Appreciate it.
Awesome. So this is kind of more of the same. I don't really want to spend a whole lot of time just looking at the riser. Do we have any questions, kind of the system architecture or the layout? Because I kind of want to move on from the network riser pages.
Yeah, nothing here. Thank you.
Cool. We'll go to kind of the first major system. You can see this is actually our penthouse system network engine, S&E. This one has all of our air handler controls, and we have VFD integrations for every single one of these. So every air handler except for air handler 9 has a supply fan and an exhaust and a return fan VFD, and each of these has a backnet connection. So this trunk is kind of full. This network trunk has a lot of individual devices on it, as well as fan coils. Same thing. So we're going to actually spend a fair amount of time in the penthouse tomorrow on the site walk. I'm going to shut down a bunch of equipment and we'll open it up and take a look at it. And there's exposed ceilings and stuff too, so we'll be able to look at the fan coils a lot better than we would by removing a bunch of ceiling tiles and stuff in the space. So yeah. Anyways, move on. So this is our basic. Oh, I'm sorry. Go ahead.
Excuse me. Just a quick question, and I know this might be a little off topic. Why is AC9 the one without the supply and return? Is there any specific reason?
Yeah. So air handler 9 is a dedicated outside air.
Okay.
So its return air is actually just an exhaust fan.
Copy. Alrighty. Thank you.
Yeah, no problem. Cool. So we show a basic panel diagram here. This is an example of our S&E panels. It's really basic. They're I don't remember because it's been a while since I've done on-site work at the VA, but we do have an unmanaged switch, which, if you guys don't want, we can remove it for you, whatever. Right now, we are using this unmanaged switch to kind of backbone all of our S&Es together. And the site itself, we have a remote cloud panel that's currently in the penthouse that is not part of the project, but it is something that we have used for the construction. So that way we have remote access to the building during the construction phases. So, but yeah, you can see it's basically just the network engine, an unmanaged switch, and a power supply. So, pretty basic stuff here. There any questions? Kind of what we're looking at?
Yeah, is there a security requirement built in the contract to lock out that feature upon turnover?
Can you give more details?
So you're saying you added something that you could remote into our system? And
Oh,
so
I'm
just
sorry.
with my,
So yes, we have added that, but that is once the construction is complete, which we're kind of coming up on that. We are removing that entirely. That is owned by us. It's not being provided to you guys basically at the end of the project.
okay, I
So
appreciate it.
that will be removed, and we will be there's a fiber connection that is in the works going between the central plant and the first floor IDF closet, which will essentially connect these 5 network engines to the existing hospital.
Okay, copy, thanks.
Yeah, no problem. Are there any other questions about what we're looking at here? So now we kind of get our first system flow diagram. Of course, we start with one of the more complex systems on site. This is our standard air handler. So you can see this is AHU 1 through 8. So that means that all of these units 1 through 8 are typical of this layout and this equipment. Some things to note: items in gray are third party provided by another contractor, but it's still shown on this flow diagram as a control object. It is something that we are still capable of controlling or monitoring in the scenario of a smoke detector, for instance, the supply air smoke detector. We don't have any control off of this, but we do monitor the contact of this. And we do have basically secondary safety within software. So that way this is sort of doubly shut down. This equipment gets shut down basically by the physical contact of the smoke detector, as well as the software will recognize that contact, that change of contact, and it will also shut it down via software. A couple of other things: these humidifier valves, steam isolation valves. These are provided by others, but we do have control wires. So these are objects that we would be essentially controlling with our controls. Yeah, so there's quite a lot of stuff here. Is there anybody have any questions about kind of what we're looking at? I know this is a lot to look at. Also on these flow diagram pages, we provide a bill of materials. So essentially we tell you what the part number for said material is, and the total quantities for the typical of 8. So yeah, this is a pretty extensive list of hardware, and that's simply because it's, there's a lot going on with these units. So are there any questions with what we're looking at?
Nothing here, thank you.
Perfect. Okay. Next up, we have our sequence of operations. Again, this is standard stuff. I'm not going to read everything. Yeah, does typical control for an air handler. One of the things that kind of stood out to me that's a little bit of a difference is most of the equipment, actually all of the air handlers, they control to a supply static pressure set point on the supply. And then the return is controlled via a differential of CFM. And now what that entails is there's essentially, let's say there's a differential of 10,000. It will wait until the supply fan is registering over 10,000 CFM to ramp the return fan to maintain that differential. So that's kind of something interesting to note. The only other thing here that stands out is essentially our control for economizer, or rather the 100% return versus economizer modes. So these dampers, they technically can modulate, but via sequence of operations, it was determined that it's basically not worth cutting our outside air in any way, shape, or form, because these are not set up as a minimum outside air setup, as in 2 outside air dampers. So these are basically 100% outside air all the time, and the only damper that really changes is the return and exhaust, which are in opposition to each other. So the sequence calls out, 100% return mode is essentially 0% exhaust. We're just bringing outside air and bringing the return back and mixing it with the outside air. And the other mode is economizer. So we close the return and we're exhausting everything from the space, and we're only using outside air. Yeah. So kind of a standard sequence of ops. I believe this grayed out section of sequence is to do with, let me see. Oh, gotcha. Okay. So this is just talking about what the unit does on startup. Not certain this needs to be grayed out. I'll look into that after this. Cool. Are there any questions about what we're looking at here? This is kind of something that we'll get a little bit more in depth on with the second training session, but I can still talk briefly about it right now.
Yeah, just one question in particular is the sequence operations when we're on emergency power. How does that change, or how does that impact it at all?
Okay, so that's a great question. So all of the air handler controls are on their own. They're all on their own controller, and every single controller is on emergency power. So when we swap to e-power, there may be a slight blip in the control, as in like we may shut down momentarily. But what I mean by momentarily is like less than 20 seconds. And then the control, basically our controllers still have this visibility, or they're still able to execute this sequence of operations without having any sort of network connectivity. So essentially what I mean is our controls can be standalone when on emergency power. So if you lose power for any reason, the controls will be able to take over in that event.
Okay. And is that clearly written out here, or is it written out somewhere?
That's a great question.
So Brandon, I think because this is the idea from was still always powered. It's not gonna when the generator is life and safety. So
this is not
should be
serving
always server powered.
This is not serving IDF rooms. This is specifically air handling units, which serve all of the floor terminal units. So this is slightly different than IDF room.
No, I think Brandon's question is about how's that going to be because you said there's going to be standalone. Your system, the control system going to be standalone.
So that's so the question is related to, so when I look at a sequence operation page, I'm looking for the sequence operation under normal power, and then because we have an emergency power system, we should also understand what is the sequence operation when we're on emergency power and if there's any difference. And so I fully understand his comments about how we operate emergency power, but I just want to make sure that it's in writing on the submittal, so that way when my when my technicians are looking at this, or if something comes up, they can go, okay, this is how these particular units operate on emergency power, for example. That's all.
Uh, yeah, 100%. Let me take note of this because it's not jumping out at me right away.
Okay. Yeah,
I
that
want to
might
make
be in
sure
there
that I'm able to.
somewhere.
I want to make sure that I'm able to provide you what you're asking for. At least some sort of. You're talking about basically just like a blurb that just says like, hey,
Yeah.
this equipment can operate standalone when in the event of you know transitioning to emergency power. I think is what you're
Exactly.
asking.
Yeah, perfect.
Perfect.
Thank you.
Okay, let me take note of that real quick.
Yeah, Hayden, my understanding was that during emergency power, the HVAC is gonna perform the same. It's not gonna change because you're supplying the power.
That's correct. That's exactly what I was just describing. But I think the commentary that we were just that we just had was centered around the fact that it needs to be clearly written in sequence. So that's kind of what I'm noting right now on my notepad here. So. Um, yeah, this might be something that we get a quick revision on this page to sort of cover that. It's a really, really good catch, really good point. Obviously, I can't display that at this moment, but I'll look into this information a bit more and determine if we are currently meeting the intent of what you're asking for, or if we need to just add a quick line in here. It
Thank
would
you
just
so
be
much.
it would be just like a basic one-liner here at the end that is just describing how it operates. So
Yeah, exactly. Thank you.
yeah, no problem. Are there any other questions about what we're looking at here on this page?
Nothing here.
Perfect. Okay, so next up we have our point schedule. So you can see this note says this is typical of 1 through 5, and like I described at the beginning of the call, there are a couple of exceptions, as in differences with air handlers 6, 7, and 8 with how they have their points set up. So this particular point schedule only applies to air handling units 1 through 5. So you can see this point schedule. I have to explain this to our subcontractors all the time, so I'm just going to give you a quick, quick rundown of how this works. You get your point name, or sorry, your basically your short term. So SAT is supply air temperature, so on and so forth. This column tells you what the point is. Really, the mechanical abbreviation is really just how it lines up on the mechanical sheet. So if you were referencing our submittal against the mechanicals, this is how things would line up. So things on the mechanicals are labeled in this way, in this column. Termination in and out, or sorry, termination out. This roughly describes where wires are going to be connected for this particular piece of equipment. So we can see, for instance, supply air temperature is going to be set up to input 1 and input 1 common on the CGM 9090. That's this controller. Then we get to the right, we get a little bit more information here. Really, if there's an intermediary device, this is something like a relay or an actuator. We're going to list that information here. But in this scenario, supply air temperature is strictly a temperature sensing device that we refer to as a TE. So this is just a 2-conductor, 22 gauge. The termination is 2-wire, and it's as simple as it gets. And we also give this reference detail shape down the right. This information becomes more important on the next page. So all of these numbers and references on this column can be found on the next page or one of the coming pages. And effectively, this is going to give you a basic wiring diagram for each of these points. So if you wanted to know exactly how, for instance, supply air temperature is wired, it's it can be found in reference detail F131. So that's roughly how you would read this page. Really, the most important information is if you're referencing mechanical, it's going to be these first three columns. So what the point is that you're trying to troubleshoot, the name of that point, the mechanical abbreviation if you're referencing mechanicals. So that information is really important. Intermediary device, if you know it's got a relay or an actuator, this will tell you how it's wired at the device. And then all of this field device and reference detail sections. So this is all the important information, these three columns, and then all the stuff on the right. Are there any questions about what we're looking at here? In the next couple of pages, the reference detail stuff will make more sense.
Yeah, on this one, are you able to share with us the information on this page that would reflect in Metasys? Is it exactly the same?
So actually everything here that is quote unquote object name is a point in Metasys.
Okay.
Yep. So every single one of these, and then this expanded ID column, this is going to be your description of the point within Metasys. Obviously, these points will likely have additional labeling telling you like which unit serves it, but this is kind of the core breakdown. So these two columns are what you're going to see in Metasys.
Okay, copy. Thank you.
Yeah. Okay, gonna move on to the next page. So this is same thing. This is air handler 6. Has all of the same equipment. The only difference is potentially how things were wired. So this is just capturing the changes. I couldn't tell you exactly what the changes are without spending a good deal of time to look at this. I mean, the thing that stands out right away is it looks like we moved one of our inputs, or sorry, one of our binary outputs on this controller. I do not know the reasoning for it, but that would be, one of the major differences. But this should have all of the same point information. This is just specifically to air handler 6. So same information, same wiring, same details, the whole 9 yards. Don't really want to spend too much time looking at this one. We'll get another exception graphic or another exception page for air handling unit 7. This one in particular gets its exception due to having multiple outside air temps and humidities. So you can see right here we have an outside air temperature. We have an outside air humidity 2. We have outside air temp 2. So you'll notice we have outside air temp 2 and outside air temp. This is because we have one outside air temperature and one outside air humidity, as well as their redundant counterparts. So this particular unit has both, basically both redundant temps and humidities for outside air. So that's the biggest difference with this particular unit. Same thing, same wiring details, same information on the right. Slightly different setup with how things are wired, as well as slightly different inputs over here, specifically the outside air temps and humidities. Cool. Let's move on. This is the last one. This is air handler 8. Again, this is an exception to the template, the typical of 5 template that we looked at first. Again, I don't know what the exact differences are. It's likely just a slightly different configuration with how which terminal things were wired on. So we provided that exception to you, basically telling you what the difference is. I'm not going to get into the details of what's different on this particular page, but just know that that exists because it has its own separate page. Same thing, intermediary devices, field devices, reference details, all that information I believe is on the next page. Here you go. Yeah, so this is our reference detail pages. So I think I specifically called out detail F131. So this is a temperature sensing unit. This is typical of all resistance-based temperature devices. we just do a standard 2-wire. So you can see it's basically just the input common off of the controller, and we wire it to the leads of the temperature sensor. And obviously that's a really simple configuration. We do get things in here that are a little bit more advanced. For instance, like this starter without safeties. This is, I believe, for the VFDs. In fact, let me zoom up. We call it out. Well, there's one of these. It's 1046. So let's take a look. It's actually this diagram. So yeah, you can see it gets a little bit more intense on a diagram like this. We go over everything from a an electrical switch high external. Basically, we're feeding 24 volts through the output of the controller to toggle a relay, and that relay gets our start stop on the VFD. You got some other stuff. This covers a lot of information here with the speed of the VFD, what the safety circuit is doing effectively, so on and so forth. So yeah, there's a lot of really good information here. We kind of compiled all of the wiring details for all of the devices that were provided. So this should cover pretty much every wiring of all of the devices that you have here. Yeah, kind of your first stage of troubleshooting a device that's not working would be check out the reference detail and see, if we're checking all the boxes with the, how it's wired, for instance.
Great, Hayden. Quick update. So Tung from engineering department, he joined us. He's one of our engineers. And then I have a curious question related to the outside air temp and humidity.
Sure.
How does the setup change when you have a green roof system like we have? And we have some of the roof has green roof, some doesn't. And with the PVC roof, I've been up there in the middle of the day, and the temperature is quite hot. But on the green roof area, it's not as hot. So how does the system sort of account for I guess the differences in the roof, and how does it get like an accurate outside air and humidity indication? Over.
Yeah, so that's an excellent question. I think worth noting, at least with our site, this project, both of these sensors are mounted approximately 12 to 14 feet up in an area that's in the shade essentially 80% of the day. So while it might pick up some of that radiant heat that you're referring to off of the laminate roofing, I think it's gonna be pretty minimal. Those sensors are, however, mounted right next to each other, and they have been calibrated within this certified meter. So they definitely read accurately. They are redundant to each other, so there's logic in the software that will differentiate between one of the sensors reading inaccurately or essentially unreliably, to then use the other set of sensors. So that sort of switching happens via the software. I don't know if that necessarily answers your question, but what I'm getting at, I guess, is the sensors are mounted high enough to where I don't believe there would be much factor on the that like vinyl roofing.
Okay.
But
Okay,
Hayden, this is
Understood.
Tom.
Thank you.
Oh,
Yeah, hey, Hayden, I got a question here too.
sure.
Because
Hey, Tom.
for our geographic location, it is very well known that the exposure between the west side and the east side could impact the reading dramatically, because we have like the microclimate condition, and throughout the year, most of I think it's in the monsoon season, we have a very humid air from the west side of the building. How you address that? Because the moisture, the moisture in the air could be impact the performance of the system dramatically.
I mean, yes, that is you are correct. I don't know which direction these sensors are facing off the top of my head, but I do know that they're not in direct sunlight. Um, that being said, there was no sequence of operations essentially accounting for outside air humidity spiking or being in a quote unquote high state. So yeah, that's a tough question. I don't necessarily know how to answer that. Other than that,
Yeah, I think on this
these
one, let me help out here. So I
sure.
think on this one, Tung, what we'll do is have the contractor, Justin Serby, note the question and then take it back to the A&E. Because ultimately, JCI performs the design piece, and I don't know if JCI, if this is like a delegated design as far as the location of those sensors, but that's something that A&E can give us some more clarity on. But it's a good question, and
Yeah, I believe we collaborated on the current location of the sensors.
okay,
I don't believe we were the be all end all in the decision making process of that.
right.
So
But we have more than one sensor. Am I correct?
we do, yes.
Okay. And then just for the training purposes, Ernie Ibarra joined us from engineering as well. He's another one of our engineers that we have.
Awesome.
Yeah. Hey guys, sorry I'm
Um,
a little late, but I'm here.
Thanks, Ernie.
No problem. Cool. Are there any questions about what we talked about here? This reference detail, I'll give a little bit of a rewind here. This reference detail page is covered in the right-hand column of our point schedules. So if there's ever any troubleshooting needs, or you just want to know how equipment is supposed to work or wired or whatnot from the electrical standpoint, it's covered in this right-hand column. So for instance, I used this as an example earlier, but if we're looking at supply air temperature, we followed this all the way to the right. We see that this is a 220, two conductor 22 gauge. It's wired as a 2-wire. It's a temperature sensing device. The reference detail is F131. So if we go to the next page where we talk about the reference details, you can see detail F131 talks about how this is wired. This is obviously probably the most simple device that we've provided. That's just an example of how you would read the point schedule. So, and obviously you get
Hey
some
Hayden,
stuff
real
that's a
quick.
little bit.
I had a quick
Oh,
question.
sure, go ahead.
Who was reviewing these? I mean, was CFM? Were you guys already getting with the round of review comments, or do we have a shot at that, or we're not allowed?
I'm not certain. This would have gone through the contracting tier, and I believe it would have gone to Army Corps. Justin, I don't know if you
Yeah, it would
Yeah.
have been submitted to the Army Corps, and then they would have forwarded it to appropriate parties. So I'm not sure who they sent it to.
Yeah, so
Yeah,
I can speak
that's
on
the
this.
usual, the
So
mechanical engineer, the DR would review this and give us his
Yeah.
comments. Yeah.
yeah, so Ernie
Okay.
and the team. So the contract has specific submittals that will go to the VA for our input directly. If it doesn't require VA input, then whoever the SRE is at the time can maybe do a spot check, or if they want to look at something specific. But we rely heavily on the mechanical DOR and the team to make sure that everything gets ironed out. Over.
Okay, because I see clouds right there. I'm like, what's going on there? But it's cool. I just making sure that everything was addressed, and that makes me feel a little bit better.
Thank you.
Because remember, this is like the first time I see it. I don't know, Tong, have you seen this or not?
Yeah, no, this will be the first time the facility sees it unless
Yeah.
you're directly involved with the project like Eric Rocha was.
Yeah.
Over.
Was
Yeah, just
okay.
Brandon, also, this was submitted 5 times. So this was the 5th revision that we accepted it.
Yeah. So it's
Oh, it was submitted
to
a lot more
answer.
than 5 times.
Yeah. Yeah, to answer Ernie's original questions, like it's had a very thorough review. And so that's probably the part that we need is just to understand that very technical folks have been looking at this for us and making sure that we get it all put together. So I appreciate that.
Pleasure.
Cool.
Tom, you have a question?
No,
Or no, just thumbs up.
I'm good. Okay.
All right,
Got a
appreciate
thumbs
it.
up, that's all. Yeah.
Okay. Cool.
Also, one thing else, Tracy would also review this somewhere else. So she gave also her input
with
before the final
AECom,
approval.
you're saying?
Okay.
Yes.
And for the team, Tracy Whaley is our commissioning agent on behalf of the government for AECom. Very experienced team, very knowledgeable, and I'm very confident in their review. Oh,
Perfect. Cool. Let's move on. We talk about the basic panel layout. So you can expect essentially every air handling unit panel is going to come with this setup. Each of these panels, and when we go on our site walk, I'll show you the exact locations of these, but each of these panels is going to be mounted on the return side of the unit, the exterior of the air handling units. And again, we're providing a bill of materials, so you get the exact count of what's in every panel. Pretty standard stuff. Are there any questions here?
none here.
Can we have the panel with a lock? And the key only be available to our maintenance staff. I don't want to have any outside contractors, to get access to the panel inside of the panel. I don't want to have like a typical.
I don't believe,
just
I
that
don't believe these are not currently set up with a key lock. I think that would be something extra, or if it's part of the spec and we missed it, then that's different.
No, it's
but-
okay. I'm just asking if we have an option like that. Yeah, I don't want to go back and create more.
Yeah,
So-
no, I can answer that. So we're planning the full key turnover at substantial completion, which hopefully is here in April timeframe. And if anything like that, Tongue, what we'll do is we'll need to just identify it as a team, as something that we need to work with our sort of M&O or locksmith or whoever we need to make that happen.
Yeah.
So, but good catch. So.
Okay, go ahead and move on. Here you go. Here's the exception for air handling unit 9. So you can see that this is strictly outside air. The reason it's an exception is because it is only outside air, as opposed to the other units, which are set up and can operate as an economizer. So yeah, more of the same. Items in gray are provided by a third party, and we have just we're essentially monitoring, or if we do use them for control, like the humidifier or the steam isolation valve, they've been provided by others marked in gray, but we still operate those. We have wired them, we operate them. Pretty standard stuff. And again, all the bill of materials covers precisely what was used to basically get all of these devices sorted out. So yeah, are there any questions?
No, none here.
Yeah, Hayden, so when I say third party, I think you mean the other subcontractors like the plumbing or fire protection, right?
That's correct. Yeah. So
Yeah.
when I'm referring to third party, I mean provided by, not JCI.
Yes. Yes. Okay.
As in the overarching hardware was provided by somebody else, and we are wiring it and either control and or monitor it.
So to everybody, so this is within our contract. It's not third party.
Oh yeah, 100%. Yes. Yes. Cool. This one has its own separate point schedule. It has less equipment because it doesn't have specifically a return fan, but this does house the points for exhaust fan 13, which is its associated exhaust fan. So like I alluded to earlier, this unit is 100% outside air, and its its return air is actually exhaust directly associated with the unit, right? So yeah, that's one of the key differences here. Same thing, we get the reference details down the right. Those are outlined in the coming pages, or it actually would have been outlined. Yeah, it was outlined in the previous reference detail. So in theory, this page might actually have to be at the end, as in right here. So I'll take note of that right now. We might have to change the orientation of that.
Yeah, thanks for that catch.
Okay. Cool. So next up, we've got our exhaust systems. I know there's quite a lot of information here. We have general exhaust fans, 26 EF-1 through 8. And these are directly interlocked, software interlocked with the air handling units. So for instance, EF1 is directly software interlocked with air handling unit 1. So anytime that we call for the air handling unit to run, this equipment is turned on, and we do not have any sort of speed control for this. This is simply set by the air balancer. We turn it on, we monitor the status. Yeah, it's kind of typical stuff. The only key difference here in this is that the exhaust fan, where is it? Yeah, the temperature and humidity. The temperature, humidity, and the flow are only provided for EF13, I believe. Actually, no, I was wrong. Sorry. The temperature and the humidity are provided specifically for EF13, and that's due to the fact that air handling unit 9 does not have return air, and our sequence of operations for humidity control is based off of return air humidity. So air handling unit 13 actually operates its humidity sequence via EF13's humidity sensor. That's a key standout here. You can see EF13 temp and humidity for EF13 only wired to AHU9 panel. So even we wrote it down here. So essentially all that wire and all that information goes back to the panel for air handling unit 9. These systems are a little bit smaller, so we're able to provide sequence of ops for general fans, as well as the next systems. This system, or this page, basically has the information for more than just the general exhaust fans. It's also got the 2 exhaust fans that serve the isolation rooms. So again, these are a little bit different. We monitor amperage on these. We do control the speed of the fan output on these as well. We have things like filter DP and pressure and flow monitoring on this. So you can see this is typical of 2. So this is just EF9 and EF10. These are specifically on separate rooftops, and they serve completely separate sections of the building. Yeah, pretty basic stuff. We also have the approximate locations where this equipment would be located, and this is in our submittal. So if you're looking specifically on site for this equipment, this will, obviously roof is pretty generic, but the area served information is pretty important, especially when you get into like the floors and which equipment the air handlers are serving. So you can see, right, like EF1 serves north side, east wind, first and second floor, so on and so forth. Whereas information for EF9 and 10 are specifically isolation rooms.
And
So-
Hayden, on that topic of the ISO rooms, I know ISO rooms lately have been a lot of troubleshooting going on there in order to maintain pressure, and I know they've I guess achieved some success there. The were any adjustments made? I guess my question is, were any adjustments made to EF 9 and 10 that would need to be reflected on this particular submittal? I wouldn't think so, possibly, but I just wanted to ask the question in case you knew.
Yeah, that's a great question. I can't speak for the changes being made to them. What I will say is this information, if it has changed via like how they're supposed to operate or the required CFM or pressure, that almost certainly has been caught in the test and balance report. As far as the overarching control of this equipment is concerned, there have been no changes to how it operates via sequence.
Okay. Yeah, that's what I thought too. Okay, thank you.
So yeah,
Yeah,
no problem.
Brandon, I know it's a different subject, but we're gonna work per the design. So whatever the mechanical engineer. So
Yeah, no, yeah, Hayden explained it really
yeah,
well. I appreciate that.
the contractor will not change the CFM to achieve that. It's gonna be per the design.
Okay, copy. Thanks, Emma.
Cool. I'm gonna go ahead and move on. I know we're technically over time. This is just more of the same. We talk about the point schedule, and when you guys get this in hand, you'll be able to, flip through and actually look at all the detail on this. But this is essentially just telling you which panel. So one panel, we have two panels for exhaust fans. One of them has this point information for EF9, and it's because it's located on the side of the roof that EF9 has. And then the other has the information with EF10, which is located on a separate roof, along with the general exhaust fans that are associated with that. Same thing, same exact thing. All the intermediate devices are relays or actuators or something of that sort. The wiring detail is everything on this right-hand set of columns. These pages are a little bit smaller, so we can actually include these reference details on the same page. So that's kind of what you're looking at here with these pages. Cool. And then you get a basic layout of our panel, our EF panel. Pretty small panel, just has a couple of controllers in it. All of the relays. So you don't see any information on relays in this panel or any sort of relays mounted in this panel because the relays actually exist at the fan side. That information is not provided in this bill of materials for the panel.
And Hayden, I don't know, this looks more like maybe some ancillary text that stayed on the Buy American under bill of materials.
Oh yeah, looks like it. Yeah, let me I'll note that down. We'll clean this up a little bit.
Okay.
There's really shouldn't be much to clean up here, but it's good getting more sets of eyes on this because people are gonna notice different things.
Yeah, I'm all for America, but yeah, that looks like maybe just got copied over.
Yeah, it's incredibly likely. Which page is this? This is 26. Yeah. 1-4. Okay. Not a problem. Cool. So now we get into 2-pipe fan coils. These are cooling only fan coils. There's quite a few of these. I don't know the exact count. I know it's as far as total fan coils are concerned, there are, I believe, more than 30 of them on site. I think it's almost 40 actually. But again, these are smaller systems. They really don't have a whole lot of point information going on. Yeah, it's more of the same. So we provide our start, stop, our status. We have a leak detector installed on these. We have our analog output control for cooling. We get our discharge air temperature. Smoke detector is provided by others, the fire alarm contractor, right? This, however, duct mounted smoke detector for automatic shutoff, see schedule. So these duct detectors, I believe, are provided on any equipment that is more than 2000 CFM, which is quite a few of these. This can be found specifically on the mechanical schedule, I believe. We didn't write mechanical schedule, we just said C schedule. Another thing to note that probably needs to be added to this is that we don't actually pick up the contact for this smoke detector. This smoke detector goes specifically to the fan coil control board. So we don't get any sort of control over when it shuts down on smoke detector. So this is hardwired directly to the unit, and the unit will shut off when these contacts open. So that might be something to actually note here in this notes section. I mean, yeah, we already wrote that it's provided by the fire alarm contractor, and it's only provided on specific units. But let me write this down. Which page is this?
And Hayden, quick question while you're jotting that down.
Sure.
What is the required chilled water temperature for the system to operate? Is there a range or a specific number?
That's a that's a really that's a tough question.
Okay, because the facility, yeah, just to give you awareness too. Facility, I believe we provide 46 degree, but in the course of the project, I've heard that our system in the new building maybe requires for 46 for facility and then possibly 43 for the new building. And I
That's
just wanted
the number
to,
that I was gonna say. It was 43.
okay.
We've found through testing and through trend data that we have a significant lack in our ability to actually control the supply air temperatures, at least at the air handler level, where we're moving a lot more water. When the temperature is greater than, like, I think we've seen it work okay when it's at like 44 degree water. But I think the sweet spot is really that 43 that was identified.
Okay. Is it written down in this submittal, sort of like the range of maximum efficiency in operation?
I don't know about the control submittal. It's likely written in the mechanicals.
Okay. Is there any part of the control system that monitors that temperature and alerts us that, hey, I'm not getting the
Yeah,
water?
really excellent questions. We are monitoring the chilled water leaving and entering temperatures
Okay.
Of the system, and this is per air handler. So we could tell you what each air handler is kind of receiving from the plant. We also have a cooling coil temperature, which is actually the air immediately downstream of the coil. This would kind of get you your like most accurately get you your temperature differential between that and the mixed air temperature. So from a not necessarily from a troubleshooting standpoint, but from a control standpoint, we would be able to tell whether it's doing the appropriate amount of cooling based on the difference between our mixed and our cooling coil temperature. This differential between these two would effectively tell us how effective our loop is.
Okay.
Again, I don't have any more like concrete information about that right now, other than that our observation during testing has been colder water is better, all the way down to 43.
Okay.
However, we have seen it operate effectively with 44.
Okay. And then what's the mechanism that sort of, is there any control mechanism that goes back to Medisys and alerts the facility of, hey, we're not getting the water temperature we need to operate efficiently? Is that just something we have to monitor on our own?
Sure. There are alarms set up in software. When we go over our second training, I'll go more in depth on this, but there are alarm extensions built into Metasys, rather that I
Okay.
built into Metasys, which have temperature ranges. I don't know what they are off the top of my head. But each air handler requires a specific supply air temperature. It's a range. They all have different supply air temperature requirements. It's something like between 51 degree discharge and like 54 degree discharge. So they all ask for different ranges, and they have very specific set points for alarming. So you will know, for instance, when we are too high or when we have too little or too low temperature, right?
Okay.
So those are actually built in as alarm extensions within Metasys. So you will get some sort of pop-up or notification in Site Management Portal when that occurs, or it will pop up in the event log, essentially.
Okay. Perfect. Thank you.
Yeah, not a problem. As far as all that information is concerned that I was just talking about, that strictly applies to the air handling units. We don't have any sort of entering and leaving temperatures to these fan coils. Would kind of be nice, but what we're running into here is kind of a limitation of the equipment to actually provide something like that. So it also was never called for this equipment to have that. So just a little bit of a heads up. The air handlers will have that entering and leaving temperature, but the fan coils will not. So cool. These are a little bit different. This point schedule is different. So it's different because we're basically controlling most of these fan coils with a TEC, which is our take on the Johnson Controls take on a residential thermostat that has backnet capabilities. You can see it's got essentially, fan speeds, voltage. You've got auxiliary contacts. You've got heating. You've got cooling. You've got again, the NC, I believe, is for one of the auxiliary contacts. You got VSF if you were going to do like analog output, and you've got only 2 BIs on this, so we monitor the supply fan status and the leak alarm, the leak detector. And then this also has the discharge air temperature and the backnet communication wire. So this information is a little bit sparse, and that's because there's really not much going on with it. We still do provide a reference detail. It's this 301, but you can see this is pretty simple, which actually devices this is the smoke detector. Yeah, so we're just monitoring dry contact off a smoke detector is what we're showing here. We say that we are. Actually, that's a leak detector, not a smoke detector. That's all it is. Dry contact off the leak detector. Pretty standard stuff. We get into, we call this steam heating 2-pipe, but this is effectively a 4-pipe at this point. This is, I believe, how it's labeled on the mechanicals as well. But you can see there's only a couple of these units exist. They're all in the penthouse. They all serve the space with the air handling units. So the space in the penthouse that's not served by the air handlers is served by these fan coils. And yeah, these have a drain pan, so our leak detector is attached in the drain pan, or on the drain pan rather. You've got heating, you've got cooling, you've got discharge air. It's more of the same. There's, same thing. Bill of materials calls out exactly what was used. So I know I'm kind of going through these quickly now at this point, but it's a lot more of the same. I went a little bit more in depth with how to read our submittals early on because I wanted us to have a better understanding when we got further into the submittal. Are there any questions about what we're looking at here?
No, but I appreciate the effort. It really helps. Thank you.
Yeah, no problem. Not a problem. Again, this is more of the same. The fan coils, it's just more applications of the same equipment. Here's a slightly different fan coil panel. So this one has actually got a panel associated with it. We use a CGM controller instead of a TEC thermostat. So this one has slightly different information. Again, it's all the same points, but this one is instead monitored by a separate T-stat and controller. You can see this has more of a typical point schedule layout. So you can see it's got the type of controller, which universal input and outputs we're using. And it's got all the same reference details of our air handling unit drawings we typically use. So pretty typical stuff. Fan coil 1.8. I believe this is another one that's got a controller rather than a TEC. So you can see, right, we call out, well, this actually does use a TEC rather than the controller. What does it have extra? Oh, right. This one uses the analog output control. At least I thought it did. Maybe this drawing isn't necessarily, oh no, it doesn't. Okay, yeah, it doesn't. Yeah, it's more of the same. Binary outputs for supply fan status and leak detection. Those are the only things that we've got here. Then we use, this one actually does analog control for these valves rather than open close. Yeah, it's more of the same. Now we're going to get into our pairs of fan coils. So these are, you can see basically these are two units that serve the same space. They act as redundancy. So these serve the IDF room 1 Bravo 132 Alpha, which I believe these are all going to be on the first floor, all of these. So yeah, we show typical of 4, and that's because each pair is laid out exactly the same, and the controls just determine which one to operate based on this provided sequence of operations to ensure that we essentially don't lose operation in these zones. And we have redundancy. I believe this would technically allow you to basically duty cycle the equipment if you're trying to get, you're trying to spread out the runtime, trying to get more life out of your equipment. You'd be able to do that with this equipment. Again, though, it's pretty standard cooling, leak detection. It's cooling only.
So typically one of them going to be on standby.
That's correct. Yes, one will be idling off. It'll just be idle, waiting for a call while the other is running.
Okay.
Okay. More standard panel. So you can see each of these pairs of fan coils, they get their own panel. So this should say typical of 2. This one has the Buy American blurb on it also. I'm just gonna write to just double check everywhere for this to make sure it's not it's not shown. It's kind of silly that it's shown, but it is what it is. Pretty standard stuff. There's every single one of these comes with a power supply, the controller, and a few terminals for power. Nothing crazy. Cool. Now we're getting into the heat exchanger. A little bit more advanced system. A little bit more going on here. This is basically a pair of heat exchangers. They operate based on demand. So more demand equals basically more steam through the heat exchanger controlled by these actuators. This is an example of an actuator that's been provided by a mechanical, but we control it anyway. You can see we wrote essentially one of these actuators is only 1/3 of the control, and the other is 2/3 of the control. So if it's only operating at like a low load, you would expect to see basically only one of the first stage of this to be opening to maintain. And we use our pumps to maintain the hot water DP, which is, we put here, it's located on the 3rd floor before terminal unit 9.4. So all of the terminal unit 9s, they all serve those common spaces that are like elevator lobby or like those like main corridor between sides. So anything that's served by air handling unit 9 is in one of those spaces. Yeah, I know there's a lot to look at here. As far as like how this controls or how this works, I don't necessarily want to get into a bunch of detail on that because there's still a whole other training that we're going to utilize for talking about how things work. There any questions what we're looking at here? It's pretty stock standard heat exchanger.
Yeah, Hayden, can you explain that those heat exchangers are going to be like a primary and secondary, or one of them going to be idle, or?
It is primary, secondary, I believe. We operate the pump continuously. We talk about the valve sequence. Basically, if it only needs a certain amount of capacity, then it's only gonna, if it needs a low capacity, then it's only gonna use the first valve. If it needs high capacity, it's gonna use both valves. I'm not actually certain these are gonna run at the same time. I don't believe they will. So it is kind of a redundancy thing. We lead lag the pumps. So pumps get lead lag, the units get scheduled, and they operate as like a redundancy. So only one of these heat exchangers will be in operation at a time.
Okay.
And you can see here we have a north wall outside air temperature. So there is sequencing in here. And I'm not trying to get into a crazy amount of detail, but how the units operate is based on they do have their own separate temperature ranges. So you can see this diagram here. Oh, as I could grab it and move it. One of the units operates on a 150 to 180 range, and the other operates on a 140 to 180. So actually, now that I'm remembering, these do actually operate simultaneously. We mix the leaving water to achieve a mix between that 140 and 150 to 180, depending on demand. And that demand is determined via outside air schedule, which is why we show the outside air temperature.
Okay. So there's no primary and secondary. Both of them must work all the time.
They both operate. Yes.
Yeah.
Cool. More stuff. More point schedule.
I'm sorry, just another question. Did you
Sure.
do you show somewhere where you have the one in the swimming pool, the heat exchangers?
Yeah, that is a separate page.
Okay, all right.
Separate. It's different piece of equipment that serves that. Cool. Stock standard point schedule stuff. I don't feel like we really need any more explanation on how this stuff works. It's pretty self-explanatory once you kind of get the gist of it. This talks about all the points that you're going to see on Metasys. This talks about the wiring details. you get the wiring details on the same page. So all pretty standard. Our panel layout. Again, more standard stuff. You can see though we have provided this secondary controller, and that's because we needed the additional inputs and outputs. So that's what we show here, and that's why it's bubbled. We needed that. Cool. And yeah, here's the pool heat exchanger. So the system, and I'm not going to go into too much control detail, but essentially we utilize a pair of valves to mix the water to achieve temperature in the pool. We have essentially two different control modes. They're outlined right here: SCI and MS patient modes. They have a 10-degree differential. There is a user interface that we've provided on site. It is when we do our site walk tomorrow, we can get a little bit more hands-on with it, but it's effectively a thermostat that allows you to swap between these points, these pool modes. Yeah, that's
So Hayden,
much
on
it.
this one, I understand that prime contractors added additional valve or valves to support the, I guess, full functionality of the system. Are those valves going to be added to this drawing or part of this drawing in any way? Over.
I'm not certain. I do believe that everything shown here is how it's installed. I'm not aware if there are additional changes. I'm not aware of it.
Yes, Hayden, there's a recent change, so that should be added.
Okay, so can you
Yeah.
flag this one for it?
Hayden, I'll throw you what the RFP did and what we did out in the field and stuff, and we can update these accordingly.
Sounds good.
All right, thanks, guys.
I'm sorry, I'm getting blown up on my phone at another job. Need one moment. Okay. 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 Yeah. So this is. I wrote this down. I guess we'll connect Justin. If there's difference in information that needs to be added here, we'll catch it. Same thing. So more point schedule. This is for every system. So not going to spend too much time on it. Get our panel diagram. Or the same. Our bill of materials looks a little different. It's likely because this page was added separately. I mean, I have it written on my notepad right now to look at all of the pool heat exchanger pages because it's likely that the layout of this is going to be different if there's changes. Cool. Isolation rooms. This equipment is essentially third-party controlled. We have it integrated to the BMS via Metasys MSTP. As far as the overarching functionality of the equipment is concerned, I can't speak for the party that provided it. But this is generally speaking the layout of the isolation rooms. Not every unit has a discharge to anteroom. I'm not sure if we have that noted. But I do know that as far as like the system graphics are concerned, we have a separate drawing for ones that do have supply or discharge to anteroom and ones that don't. So that is a minor difference that we could probably get away with just putting a note on page. Yeah, there's a lot of information here. But yeah, are there any questions about what you're looking for? I'll do my best to answer them if I know the answer, but a lot of this is provided third party, and the reason it's in our submittal at all is because we integrate it via BACnet.
No, nothing here. Appreciate it.
Cool. Again, any page that shows that we're serving a lot of spaces, or that we're, we have, typical of 6 isolation rooms. We will provide a table like this that will outline the rooms being served. So the information is here. It's also on the mechanicals. You might not have to dig for it as hard in our submittal as you will for in the mechanicals, but yeah. So look, so this comes directly from the Antec manufacturer. Basically just the wiring detail, how it was wired, the pictorial of it. Yeah, there's not really much to say. It's just sort of a manufacturer provided drawing that we pasted onto one of our submittal pages. So this does cover like room inputs for, I don't know if these are pressures or its own network. Then we do have the BACnet stuff. I believe these in and outs hook up to their control valves, their supply and exhaust valves. So each of these systems has its own isolated control network for their supply and return valves, or supply and exhaust valves. And then the overarching system speaks to us in BACnet and is connected into our daisy chain. So that's kind of what's being shown here. It's not, doesn't give a whole lot of information that that's how that works, but that is how that is laid out. I don't know exactly what we're looking at here. Gotcha. Okay. Yeah. So this has got the potentiometer or potential control for the valves on it. Yeah, kind of stock. Goes straight to the actuator. This is the room pressure monitoring panel, or the basically there's a T-stat and a little annunciator, the wiring detail. We also have a horn strobe, it looks like. So when this horn and strobe gets triggered directly via the Antec controller, I'm assuming that this is based off of pressure. When pressures are out of range, it's gonna get all the bells and whistles going. So yeah, not a whole lot for me to really speak to on this, other than it shows you kind of how this is wired, or how they've set this up. So this has got your kind of physical installation of this. So you got your room LCD and your pressure monitoring annunciator device. It's basically their internal architecture. So what I was talking about earlier, how we go basically BACnet MSTP directly to their device, and then downstream of their device, they daisy chain their internal architecture off of that. And then we pick up the next MSTP device on the trunk. So they did a really good job illustrating what I was kind of talking about. This gives you the floor plan locations of each of the isolation rooms, or basically which rooms they actually are. It's kind of hard to see it in these details. And really, you would get a better idea of where everything is located in the mechanicals. But yeah, just basic call out of where those locations are. Talking about, I think this is talking about their internal network riser. They have basically their own internal network that gets all of their devices, and we just sort of connect up to only one of the devices at a time, or I think it's two of them. So the pressure monitor and the actual isolation room control board. So yeah, I think this is talking about their network. Cool. Get a lot of point information from Antec. The stuff highlighted in yellow is stuff that has specifically been provided. So you can see we get room pressure set point, room pressure, your high and low alarms, your airflow offset. These are airflow control valves, are similar to like a Price air valve or Phoenix valve. It's going to have pretty similar control of that. You use offset to get more, or to basically change your supply and exhaust to get your room pressure. That's how they've been balanced. You get a bunch of other typical points, but are not necessarily points that have been provided, or maybe all of this is provided. Not sure why we highlighted these, because some of them are, some of this, like the actual airflow offset, we want to know what it's actually doing. So I'm fairly certain all of this has been provided. Yeah, it's just an overarching list of the controls points, the backnet controls points. Cool. Next up, package dehumidification unit. We refer to this as the PDU. This is another third-party piece of equipment that we're picking up via backnet MSTP. So this is another one of those kind of we get what we get kind of thing. It does have a sequence of ops. Not 100% certain when this works, but I'm assuming if it's too humid, if there's too much humidity, we enable this to lower the humidity. You get a basic list of backnet points that were provided to us: zone temp, humidity, the occupancy, the start stop, the relative humidity set point, all these other things, some alarms, so on and so forth. Yeah. Now we get into terminal units. These systems have very few points associated with them, and that's why there's a lot of information on the screen. kind of gets me laughing a little bit looking at all this information, but yeah. So internally, these VAV controllers, they utilize discharge air velocity pressure to determine CFM. So it uses two pressure reference points to determine that. We've got our zone temperature, our discharge air temperature, and our heating output. Every single one of these terminal units are served via a air handling unit upstairs. And I explained the nomenclature for them at the beginning of the call. But essentially, we say these are labeled basically like building numbers, the first set of numbers that you see, and then the type of unit. And then the next number that you see is the unit that serves it, followed by the number that the equipment is. So you could, for instance, have TU, it could be 26, that's the building number, TU terminal unit. And then it could be like 1-1A, which would be served, it's terminal unit 1A, and it's served by air handling unit 1. Very basic sequence. You cool when it gets over 75, you heat when it gets under 70. These are all adjustable set points, 5 degrees between heating and cooling to be maintained. Very, very typical stuff. You do get your point schedule. I can't believe it's actually small enough to fit on this page, but yeah, you do get your point schedule on this page also. You can see we've only got discharge air temp, the velocity, pressure, the heating output, the damper control, and the zone temp, set point, and occupied. Each of these controllers is built with an actuator, an onboard actuator. So these controllers actually mount directly on the shaft of a VAV box. Operate that. Do we have any questions what we're looking at?
None here.
Perfect. This is more variations of the same. So the previous one was called out as a CAV. So this is just going to maintain one volume of air constantly, determined via test and balance in the mechanicals. These, however, are labeled VAV, variable air volume. So these are going to change CFM set points based on whether or not we're occupied, unoccupied, or whether or not we're heating or cooling. Heating is typically going to be lower CFM, quite a bit lower. It's going to be like 20% of the max or something like that. Yeah, really not much variation here other than it. We can modulate the VAV damper to minimum position based on the setting. Okay. We do call out one of our units with a three-way valve, or the numbers of units that have three-way valves. We've also called out which units those are. There are 11 total. Again, there's functionally no difference in how this is going to control to the typical CAV controls, other than that these have a three-way valve. So pretty stock. Same thing with our terminal unit VAV with three-way reheat. We call out 17 of these. So this is, again, the same as the terminal unit VAV with the two-way valve. Functionally, it operates the same way, but this one has a three-way valve. So when we're not using, basically when we're not heating, we're bypassing that water back through the loop. Cool. All right. Now we can do our room schedules. I'm not going to scroll through all of this. I'm not going to talk about all of this, but this is effectively which piece of equipment serves which zone. You have the system name and the mechanical drawing that supports this information. In these two columns, you've got the name of the space, the room number, the building and floor, as well as some of your air balance settings. This comes specifically from mechanical, so I'm not 100% certain if this is like perfectly accurate. Your best bet is to use the test and balance report to determine if, what these values are supposed to be, because this is the initial values from mechanical. Okay, and there's plenty of pages of this. I think that's it. And then our valve schedule. So this gives you all of the information about our valves, our flow, our GPM, our delta, right, our pressure drop, so on and so forth. You get it all here. It's in a handful of pages. This is obviously a big table. It's really hard to look at, but it's all here. All of our valve selections, how they're controlled, the size of the valve, the size of the pipe inlet, so on and so forth, whether it's got a failure position or not.
Hayden,
Yeah,
a question on the valves, and
Sure.
you may not be able to answer it, and that's fine. So when I'm standing in front of a patient bathroom toilet and I open up the access panel, typically I see 3 valves there. But in some locations it's 2 valves, and in some locations it's 1 valve. And so I'm trying to get a sense of like, the question is simply this: do you know why that configuration in the patient bathroom access panel, why does that configuration change across patient bathrooms? Because I would expect it to be the same. And it looks like some of those valves have power or control mechanism tied to it, and some don't. So
I
again,
see.
if it,
Yeah, that's interesting. I mean, I don't necessarily want to speak for mechanical on this, but my understanding, if you're seeing some sort of manual isolation valve, this is for obviously it's for isolating your controls actuator. If you're seeing sort of a circuit setter like dial valve type thing, or like a CT valve of some sort, you typically don't want to touch that one. That one's set by test and balance, and it's set for a very specific amount of flow. You likely would see three valves in that scenario. If that said configuration had a 3-way actuator, is my understanding of this.
okay.
Right. If you just have a 2-position actuator, you just have a standard in and out. Whereas if you have your 3-way actuator, you've got your in and out, but you've also got your basically it bypasses when the valve is shut. You're gonna bypass that water from the supply directly into the return, and then it's gonna go back to the loop, right? So you likely have 3 isolation or 3 sort of valves. It's 2 isolation valves and a circuit setter type configuration, as well as our actuator. But yeah, I wouldn't quote me on that. That's kind of
Okay.
my understanding of it.
No,
So-
that helps. And yeah, I'll get some more clarity from the mechanical side of the house, but thank you. That
Yeah,
helps.
yeah, no problem. Cool. So yeah, that's kind of it. We talk about all the valves, the trends and alarms list. This is everything on site that we have trended and alarmed. There's a lot. Yeah. And after that, we get into the next like 50 pages of material, which I'm sure we all have plenty of time in the day for me to go over that. I'm joking. I definitely don't think I'm going to go over 50 pages of material right now. But essentially, the final pages of our drawings are essentially, actually, this looks like this is specifically actuators, because there's going to be more. There should be more than 50 pages of material for a job this large. But this is all actuators. So this is all referring to the Belimo stuff that was called out in the valve schedule. So yeah, I know that was a kind of a long-winded explanation of our job. I'm glad you guys stuck through it. Are there any questions or closing comments before we kind of wrap this up? I think this was a productive kind of page turn of our submittal. Hopefully I didn't, bore you too much, or hopefully I didn't go too slowly, but
No, that was really really great, Hayden. Appreciate it, and glad it's recorded for the rest of the team. And I like that we were able to catch a few things to help tighten it up, and so I appreciate that effort as well. And then anyone on my team, do you guys have any remarks or comments before we wrap up?
No questions at this time. I know there's a lot of info in here, so it's gonna be on myself to dig through it. But thank you for taking the time to walk us through it today. Appreciate your time.
Thanks, Joe.
Thank you.
All right, turn it over to I guess Justin or Iman.
Yep.
All right, I just stopped
Hey,
recording.
Hayden.
Thank you, guys.